In this video, I will be explaining the process of making bread and how it applies to chemistry. Today, I will be making a basic white bread in a Dutch oven. To start, I have gathered the typical ingredients needed to make bread. These include water, sugar, flour, yeast, and salt. To begin, I measured out 9 grams of yeast. Yeast are single-celled microorganisms. Although we can see yeast with our eyes, they are microscopic. It takes 20 billion yeasts to weigh 1 gram. Next, I measured 4 grams of sugar. Sugar is a chemical compound made up of 12 carbon atoms, 22 hydrogen atoms, and 11 oxygen atoms. Then I measured out 300 grams of warm water. Water is made up of 2 hydrogen atoms and 1 oxygen atom. Once I added the water to the sugar and the yeast, I let the 3 ingredients sit in the bowl together for 10 minutes. Here is a time-lapsed recording of the yeast reacting with the sugar and the water. After about 10 minutes, I felt the bowl and it was warm. This shows me that the reaction that takes place is exothermic, meaning it can produce energy in the form of heat. This is happening because more energy is released when the bonds are formed in the products than is used to break the bonds in the reactants. The yeast undergoes 2 processes within one chemical reaction in this stage. The chemical reaction is sugar, an aqueous substance, being broken down into ethanol, an aqueous substance, and carbon dioxide, a gaseous substance. The first thing the yeast does is an aerobic, or requiring oxygen process. This process is called respiration. The yeast eats the sugar and breaks it down into carbon dioxide. Carbon dioxide is made up of 1 carbon atom and 2 oxygen atoms. This is what causes the bubbles to appear and the mixture to expand. Other process that happens within this reaction is an anaerobic, meaning does not require oxygen process, called fermentation. Besides making bread, fermentation is used to make silage for animals and to produce alcoholic beverages. Fermentation is the process of yeast eating sugar and then excreting ethanol, a type of alcohol, which has 2 carbon atoms, 6 hydrogen atoms, and 1 oxygen atom. Here is the chemical reaction that causes both respiration and fermentation. The carbon dioxide produced gives the bread its rise, and the ethanol produced gives the bread its flavor. These 2 compounds are the products of this chemical reaction. It is a chemical change because 2 new products have been formed. This is a decomposition reaction because 1 compound, sugar, is broken down into 2 other compounds, ethanol and carbon dioxide, with the help of yeast. Here is its balanced reaction. Next, I added 400 grams of flour. Flour is made up of finely ground wheat grains. It consists of insoluble proteins called gliadins and glutenin. When it combines with the water, the glutenin and gliadins begin to form a gluten network which can trap the carbon dioxide bubbles produced by the process of respiration. Gluten has viscoelastic properties that help the bread rise and produce a chewy texture. Mixing the flour with the yeast and sugar also ensures even distribution of the yeast and allows the amylase, which is an enzyme found in yeast, to break down the flour into simple sugars called glucose, sucrose, and maltose so that it can eat them and excrete more carbon dioxide and more ethanol.
这一次我真的睡着了。
Next, I added 8 grams of salt. Salt is made up of 1 sodium atom and 1 chloride anion. Salt is essential to bread making because it prevents the bread from rising too fast. This is important because if the bread rises too fast, there is no time for the ethanol to develop, and therefore the bread will be flavorless. Salt does this by inhibiting yeast growth. Salt also reacts with the gluten network to produce tighter gluten strands that can therefore support the carbon dioxide produced through respiration and therefore contribute to the rising of the dough. I measured the height of the dough and it was 6 centimeters tall. Then I covered the dough in plastic and let it sit on a warm countertop for 1 hour. During this hour, the processes of fermentation and respiration continued to happen as the yeast found more sugars to eat and produced more ethanol and carbon dioxide. This period of rest time for the dough is called rising, as the dough literally rises. When I measured the dough again, it was 10.5 centimeters tall. When I was removing the plastic from the bowl, the gluten network stuck to the plastic. This shows me just how much elasticity is found in the gluten network. Next, I floured a cutting board and dumped the dough out of the bowl. Again, the dough was sticking to the bowl via strands of the gluten network. I then proceeded to fold the dough into itself. This process tightens the gluten network even further so that the loaf can stay in its shape. It also ensures that the carbon dioxide bubbles produced from respiration are equal in size throughout the dough. Then I smoothed out the folds in the dough by dragging the dough across the cutting board in multiple positions. Then I covered the bowl with a linen towel and coated the towel with flour for easy cleanup. I let the dough rest for half an hour. This is the final rise, and it was referred to as proofing. After proofing was finished, I put the dough into the Dutch oven, which had been preheated to 460 degrees Fahrenheit. I put it in the oven, which had also been preheated. I cooked it for 30 minutes with the lid on and then 15 minutes with the lid off. While cooking, the yeast died due to the elevated temperatures and therefore became inactive and caused the bread to deflate a bit. During the final bake, the crust caramelized, which is a chemical change. Caramelization results from oxidizing sugars which are found on the exterior of the bread. This results in the crust being brown. When I cut open the bread, it was moist and had even carbon dioxide bubbles throughout. It was a success. I hope you learned lots about how to make bread and how it's related to chemistry. Here are my references. Thanks for watching!